Welcome back to the Rochester Institute of Technology, where today we will be discussing a sample preparation, sample loading, and software tutorial for the Shimadzu EDX-8100 EDX XRF system. First, when preparing your sample, you will need the following materials. If you're working with a powder sample, you will need a mortar and pestle, a spatula, a sample cup, the sample cup base, your sample, and the sample cup film. Now for sample preparation. First, we are going to prepare our sample cups. You can either use the ultra lean or Mylar circular window films. On the sample cup, you'll know it's the bottom because there are two small notches on the bottom. And for the base, on the ring, you can feel that it's slightly ridged. Today we are using the Mylar film. There's a small piece of wax usually over it. So you're just going to put it onto the base. It can be a little staticky. And then you are going to press the cup into it. This may take a few tries, and it does take a little bit of force. At the end, you want to make sure it is very taut and tight across the bottom. Now that we have completed our sample cup, we are going to get our sample ready. If you're working with a powder, today we're working with calcium oxide, you will want to crush it up in a mortar and pestle until it is entirely consistent. I always like to clean off the spatula with a Kim wipe before I begin, as well as the mortar and pestle. If you would like, you can also use IPA to clean it as well. Today we are just going to dump some of our sample into here. And we are going to use the mortar and pestle to crush it up and make it sure it is entirely consistent throughout. After you've gotten it clean to your liking, we are now going to just scrape the sides to get all the powder down at the bottom. This can just make it easier to get it into your sample cup and make sure that it is all loose and off the inside of the bowl. And we're just going to scoop our sample into the cup. You'll want to make sure that your sample cup is around at least halfway full. Again, I'm currently scraping the sides because sometimes the powder can get stuck to the sides. You'll notice that I shook it and tapped it to see how full it actually was. And from there, it looks like we are in a good spot. So it should be around that full. When you go to the EDX station, you will see the filter list on the computer, the monitor, the vacuum pump, and the Shimadzu EDX-8100. With our EDX system, you have the ability to use helium in your method. So, if you intend to use helium, you will have to start by turning on the helium turret behind the computer monitor. Also, to the left, you can see the regulator. On the right side of the instrument, you will see both the instrument power switch and the X-ray power key. You will have to turn the instrument power switch into the on position and rotate the key into the enable position in order to use the instrument. On the front of the EDX, you will see the indicator lights and latch release button as indicated in the lower right photo. From left to right, the lights include the shutter open, which would indicate that you're in the middle of a run, the power light, the X-ray on light, a ready light when the instrument is ready to run your sample, and finally an error light that will appear if there is an error with the instrument. Furthermore, the latch release button can be used in order to open up the sample chamber. And in the image above, you can see the sample turret. This instrument can actually hold up to 12 samples at a time. All of the different positions are labeled for easy method development. And now we are going to load our sample. First, you will press the latch release button and open the chamber. From there, you'll notice that all of the positions are labeled. This can be helpful when you're making your method. All you have to do is put your sample cup into the position and you should be good to go. Now we are going to move on to our software tutorial. First, you will log into the EDX computer using your RIT username and password. From here, on the left of the desktop, you will see the PC EDX Navi software. You should start by opening this software. After a few moments, when the software is completely loaded up, you will see the window on the left. First, you will have to start by clicking the Initialize button. It may take a few moments for it to initialize. However, from there, you will be able to see in the top left corner that it has completed its initialization. From here, you will click on the X-ray on button in order to turn on the X-ray. This also may take a few moments to load up. After the X-ray has completely turned on, the screen to the left will appear. As you can see in the navigation panel, the entire startup process is now complete and it's time to move on to the check analysis. In order to conduct the check analysis, you will have to insert the calibration standard into the instrument in the one position. Down below, in the images to the left, you can see both the calibration box and the correct calibration standard to use for this step in the process. You should be able to find this in the drawer that is just to the right of the instrument. Furthermore, after you have loaded the calibration standard, you will click Measure. It may take a few moments to conduct this measurement. From here, you should see the screen on the right appear when the instrument has completed this part of the check. If the energy check or intensity check do not come out okay, please come talk to Tom Alston or simply run it again. After clicking on Usual Analysis, the following monitor to the left should appear. From here, you can see that the check analysis is completed and in blue, and now we are on to the preparation for our run. You are going to click File and you are going to click New Group. From here, you can pick whether or not you would like to use quantitative or qual-quant, and then click Create. Now it is time for us to create our method. you can see that we chose the qual-quant option as indicated at the top of the group condition box on the left. From here, we have several different options in order to optimize our analysis. First, in the group measurement conditions, we have the collimator, which we generally have set to 10 millimeters. From there, we don't actually have a spin option for this instrument. You can select the atmosphere, which again, you can either choose in air, vacuum, or helium. And from there, you would select the type of the sample cup, which should be indicated on the sample cup film box. Furthermore, you can go to the online output. The primary point that you need to be considering here is what units you would like to analyze your samples in. Today we are doing the percentage, so it will give us the percentage of each compound in our molecule or in our sample. From here, you can see our sample form. Today we are using our powder form, so it's just going to be in bulk. From there, we're also working with calcium oxide today, and so we are actually going to change the compound form to an oxide. And you can simply do that by clicking the oxide button. Next, since we know that we have calcium oxide in our sample, we are going to go to the channels for measurement, and we are going to click the periodic table button. From there, you will be able to select calcium, which is what we are doing today. However, for your sample, you would choose whatever compounds you know exist within the sample. Next, you should hit the analysis information at the bottom left of the window on the previous slide, and this window should appear. So we can see that we have decided to go with a calcium channel, and from here we are going to click on the measurement conditions button. Now, you can see based on the analysis range, the KEV, that it's going to be 3.49 to 3.89. From here, you are going to decide which filter to use, and it should be indicated on the sheet of paper that is attached to the computer itself which filter you should use. In this scenario today, we are going to use the filter number 2. Make sure you hit apply before Xing out of this box. From there, we are now back into our group condition window, and we should be all ready to get going. So you can simply hit file and save, and then it will come into this area where you can give it a group name and give it a comment before finally saving it. After you click save, it should bring you back to the measurement preparation window. As you can see, I've now given my sample a name. I've commented that the analysis is for this tutorial, and I've noted my initials under the operator, as well as selecting that the condition was the tutorial run that I just developed. If you are running multiple samples, it is important to see if you go up to the sample image title, just to the right of that there is a star button. If you click on the star button, you can actually indicate how many samples you have, as well as giving them a name in their specific position, simply by clicking on each of the circles that you will be using, and you should be able to get specific positions in order to fill in the titles for each of those samples that you add. And from here, you should be ready to run things, and you can press start. After you press start, you can see in the navigation panel that we are now onto the measurement part of the analysis. And you can see in the top right corner that it actually indicates the amount of time you have to measure. Currently, on the left side, you can see that this is what you should see when your run is being prepared. From there, once it actually starts measuring, you will start to see what is on the right. Finally, after the run has completed, you can see in the navigation panel that we are now in the results section of the analysis. We simply used calcium oxide, and so you can see that it is 100% CaO. This knows that we are working with oxygen because we indicated at the beginning during our method that we are working with a metal oxide. So furthermore, you can see that if you have more than one sample, you can go on to next sample and it should begin to run your next sample in the queue, or you can click on the report key. And if you click on the report button, you will see the following on the right appear. You can save this, you can export this as a PDF, and it should indicate everything that happened in the run, including an image of your sample in the instrument, the percentages or the ppm of the different compounds in your sample, as well as showing the graph that was taken during the run. Thank you for watching. If you have any further questions or would like to schedule an in-person training, please contact the RIT School of Chemistry and Material Science Instrumentation Lab Manager.